So this video is about creating a histogram, which is another kind of graph that works well for quantitative continuous variables. Okay, and this is in that data for describing distribution spreadsheet which I've linked to in Google Classroom. And this is just 49 kinds of cereal, and this is the percent of the calories that come from sugar in each of these cereals. And what we're going to do is we're going to do a similar kind of graph where we're going to make a histogram like this, but a couple of pieces that go beyond that is a frequency table, and then you use that to make the graph. Now the graph I make is not going to be exactly like this because I'll let the computer do this, and that's another element that I'm going to show you how to do. Um, but that's later on. So let's talk about doing this let's talk about making a histogram for this. Now, one nice thing about this is I've sorted this data all for us, so I don't have to worry too much about it. You'll see one piece that's a little different. It makes it a little easier because it is sorted. So you should have this. A couple of you. This isn't about Super Bowl attendance. This is another table. I use something different for that with the in-class people, but we're going to use this table for that. Now, what we try to do with the histogram is you sort the data into bins. Instead of having a dot for each piece of data, we're going to clump the data together so it's easier to graph and we get a better picture of it. So we try to do a dot plot with this, there's going to be a zillion dots. Well, there'll be 49 dots, and we don't want that. That'll be a pain. So what you do is the way you've come up with, so what I'm going to decide is how many bins do I want? I mean, how do I group them? Bins class is another name for that. So the experts say you want more than 3 bins, but fewer than 20 bins. If you only have 1 or 2 bins, it doesn't tell you much. I mean, if you have more than 20, it can be too busy. We also want to try to avoid gaps. Not that a gap is a bad thing. I mean, like, see how I've got this one here? There's no gaps. Every bin has some height to it, has some numbers in it. So that's okay. Sometimes you can't get rid of the gaps, and that's fine. There's no right answer. It's just these are suggestions. So so how do you decide? So what I'm trying to show you now is how do you decide how wide to make these bins? Well, I'm going to look at my maximum value, and I'm going to look at my minimum value, and then I'm going to divide by, well, how many bins, number of bins, how many classes do I want to sort this data into? Remember, more than 3, but fewer than 20. So I see my lowest value is 20, my highest value is 60.3. Well, let's see, 60.3 minus 1, and then I got to think about how many bins I want. And I want to make this easy if I'm doing this by hand. So I see this is 59.3. Well, for this data set, isn't this pretty close to 60? That's just about 60. So if I divide this into 10 bins, or actually let's even do this. Let's just make these 6 bins, okay? If I do 6 bins, 60 divided by 6 is 10. So that's going to tell me I want each bin to be about 10 wide. These are what? These are 9.29, I guess. I don't know. I'm guessing that's what the computer said to use. So, and I see my lowest value is 1. I could start with 1 here, but why don't we just start with 0 since it's so darn close? It doesn't have to match the data perfectly. And then because I decided to make these 10 wide, I'm just going to increase them by 10 each time. Let's see. Let's see, 30 can't add 10, sorry, 40, 50, 60, and I could go to 70 because I got to go big enough to catch that last one. So I'm going to put 70 here, but you'll see in a minute we don't need that. Now, I don't want to be able to I can't put 10 here. I can't say from 0 to 10 and then have 10 start here because that would tell me that 10 could go in 2 different bins, and we can't do that. We want to be able to sort it in 1. So one way to do that, because this data is used in 1 decimal place, we can say I'm going to go up to 9.9. So that bin, I'm going to mark if a percentage of sugar between 0 and 9.9, I'm going to mark it here. And then I'll do the same thing here. This is up, let's see, 1/10 less than that will be 19.9. And 1/10 less than that will be 29.9. What are you noticing these are going up by? I hope you say 10, just like that. So we could finish filling this out by just adding 10 to each one, or you can keep subtracting 0.1 from each. Either way gets you the right answer. So 59.9, 60, 9.9. Now, do you see how what I said I don't need the 70? My highest is 60.3, and I catch that in here. So I don't need that 70. And that gives me how many bins? 1, 2, 3, 4, 5, 6, 7. Usually it works out for me. I say I'm going to pick 10 and end up with one more. And it's just the way I set up the numbers. And nothing's wrong, nothing's right. You'll see with the software, it makes it very easy. Now, this bin middle, this is just for graphing ease. So what I'm going to say halfway, I could average those two and write the bin there, or I could just say halfway between 0 and 10 is 5, and that's going to be 15, and see how this goes up by 10. 35, 45, 55, 65. Okay, and that just makes it easy to mark it on the graph. Now, if this data was all jumbled up, you'd have to go down to, okay, so I've got one that fell here, I've got one that fell here, I've got 5 that fell here, that kind of thing. And you remember how to do those tally marks. That helps you sort it. You probably will not have to do this if you sort your data on your spreadsheet. Okay, so just so you know. But we do need to get the counts. So let's see. I'm going to hopefully hold this so you guys can see it. I'm going to do everything between 0 and 9.9 in this first bin. And there's 10. So I'm going to put 16 cereals get sorted in that first bin. Then I'm going to go from 10 to 19.9 right there, because that's 20. So that's how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 in that bin. How many between 20 and 29.9? 1, 2, 3. How many between 30 and 30.9? Well, let's see. 1, 2, 3 again. How many between 40 and 40.9? Wow, a lot of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many between 50 and 50.9? Let's see, 1, 2, 3, 4, 5. And then only 1 in that last bin. Okay, now, relative frequency, sometimes it's good not just talk about counts, but talk about what percent of the data fell in there. So I've got 49 kinds of cereal. 16 of them fell in this first bin. So if you think about, Dr. Carson talks about calculating a percent by you put the is over the of times 100, or maybe she said part over whole times 100. You've also Mrs. Hatch or Mrs. Wozni, if you had Mrs. Wozni in 7th grade, or Mrs. Sutherland, if you're watching this in the future. They might have taught you this, the is over the of equals percent over 100. It's all the same calculation. I think for this situation, one of these is easier. So 16 divided by 49 times 100. Why did I divide by 49? I hope you said because there's 49 kinds of cereal. Why is 16 on top? Because there's 16 in that bin, all right? So let's see. I don't know if you can see my calculator, but I'm going to do 16 divided by 49 times 100, and that gives me 32.7. 32.7% fell in, almost a third, right? Because 33 and a third is. So then the next one will be 10 divided by 49 times 100. So 10 divided by 49 times 100. What times 100, Dan? Times 100. So 20.4. Now I hope, do you have to see me write 3 divided by 39? Because it'll be 3 divided by 49, and then make that a decimal, times it by 100, so 6.1. And this is also 6.1%. Then we're going to do 11 divided by 49. Notice I'm not even bothering multiplying by 100 now, because I just know I got to move the decimal point 2 places over. Didn't know this would be going to be mathematics either, huh? 22.4%. And then 5 divided by 49 is 10.2. And then 1 divided by 49 is 2.0, I'm going to round to. Now, hopefully, this should add up to 100%. If it doesn't, it's because of rounding error, and that's okay. It should be darn close. It's probably like 99 point something. Now, once you get your frequency histograms, frequency table set up, you want to make your graph. And my variable is percent sugar. And then what I'm going to graph is I'm going to graph the frequency. So then we got to come up with a scale. I see I got to go up to 65, and as long as I'm consistent with my width, and I'm starting at 0, so I don't have to show any broken line graph. I can just keep going. So I think what I'm going to do is I'm going to go, I'm going to do what? I've got how many lines? 7? I mean, I've got 7 bins. What if I make every bin 3 wide? 1, 2, 3, 4, 5, 6, 7. That'll work. And then I'm going to put my bin mark. This is why the bin mark. See, I could write 0 to 10 to 20, or I could just write underneath it my bin mark, which is 5, 15, 25, 35, 45, 55, 65. See, I almost think this is cleaner than having all those little numbers there. Then my counts, I'm going to go up to 16. Do I have 16 lines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I do. So I'm just going to have every line worth 1. If I didn't, I would have to double it up or triple it up or whatever. 5. Oops, I should have put the 5 over here. 1, 2, 3, 4, 10. 1, 2, 3, 4, 5, 15. And then for the first bin, I've got 16. The first bin, I've got a count of 16. So I'm going to make this first bar go up to 16. Now, if you want to get fancy, you can shade them in or color them in. Then I've got 10 in the next bin. And while I'm coming over 3, I don't want to have different widths, because if I have different widths, that messes up the look of the graph. So that's 3, that's 3. Then I've got an 11. Oh, of course, there always has to be an oddball, right? Doesn't follow the trend. Then there's a 5. And then there's a 1. I don't know about you. If this is, so I'm seeing 2 clusters of cereals. So I'm seeing a bunch of low cereals that have very low calories, very few sugars, grape nuts, probably Wheaties, those kind of cereals. And then I've got a cluster of fairly high calorie cereals or sugar cereals, Fruit Loops, those kind of things, Captain Crunch probably. But generally overall, I see a trend like my right foot. So I'm going to call this a right skew distribution. And we're going to learn the next unit, we're going to talk about measures center, and we'll learn how to use the mean and the median to make this determination too. But that's what you got to do. So go pick your the spreadsheet that you made. Pick a quantitative continuous variable. Remember, make sure you use a continuous one to make it easier. It'll be this work will be much easier for you if you do. And you're going to fill in this table and come up with it. So to recap, make sure you do, when you finding your bin width, how wide to make these bins. You do the max minus the min, do some rounding to make it easy, and then decide on how many bins you want between 3 and 20. And then you can come back and watch the rest of this video, and again, if you need it, or you can reach out and get some help. I can help you live on Zoom. Okay, so that's your creating your histogram. This table and your histogram, and talking about the shape is the graded assignment. You can put that, you can scan it and put it into a Google Doc if you want and share that.